Hello, space and science enthusiasts. Today we will explore an unknown and dangerous aspect of space travel. Let's start by saying, Houston, we have one more problem. A new study shows that space travel can have serious effects on our brain health. Let's take a closer look at this exciting but worrying topic. A study published today in the journal PLOS One reveals that galactic cosmic radiation, the same radiation that bombards astronauts on deep space missions such as Mars, may accelerate the onset of Alzheimer's disease. Galactic cosmic radiation poses a significant threat to future astronauts, says Professor M. Carey O'Banion of the Department of Neurobiology and Anatomy at the University of Rochester Medical Center, URMC. It has long been known that radiation can cause health problems such as cancer, but this study shows that radiation exposure during a mission to Mars could lead to cognitive problems and brain changes associated with Alzheimer's disease. Space is full of dangers, not least of which is cosmic radiation. Fortunately, Earth's magnetic field protects our planet and people in low Earth orbit from these harmful particles. But when astronauts leave orbit, they are exposed to a constant rain of radiation. They can be shielded from dangerous types of radiation, such as solar flares, but not all types of cosmic radiation can be effectively blocked. Earth's magnetic field largely blocks harmful radiation from the Sun and the rest of the galaxy. This natural shield protects us from countless dangerous particles every day. But when astronauts leave the Earth's protective field, this protection is lifted, exposing them to the direct impact of cosmic radiation. NASA is planning manned missions to an asteroid in 2021 and to Mars in 2035. These missions will expose astronauts to cosmic radiation for long periods of time. The journey to the red planet could take 3 years round trip. NASA has been conducting research for more than 25 years to identify the potential health risks of space travel and develop countermeasures. One of NASA's primary goals is to understand the effects of space travel on human health and to develop countermeasures against these risks. NASA is constantly working on new research and technologies to minimize the dangers that astronauts may face during long-term space travel. To date, many studies have shown the effects of galactic cosmic radiation on cancer, cardiovascular, and musculoskeletal systems. But the study published today is the first to examine the potential impact of space radiation on neurodegeneration, specifically the biological processes that contribute to the development of Alzheimer's disease. This research shows that space travel can affect not only our physical health, but also our cognitive health. Our brains are highly susceptible to the harmful effects of cosmic radiation, and prolonged space travel can accelerate the development of neurological diseases. The researchers studied the effects of high-mass, high-charge, H@ZE particles. These particles move through space at high speeds, powered by exploding stars. Iron particles were chosen for this study. Iron particles have a bigger impact, and from an engineering point of view, it is extremely difficult to effectively block them, says O'Banion. We would have to surround a spacecraft with a 6-meter block of lead or concrete. H@ZE particles are among the most dangerous components of galactic cosmic radiation. They travel through space at incredible speeds and can penetrate solid objects. Protecting spacecraft and astronauts from such radiation is a major engineering challenge. At NASA's Space Radiation Laboratory at Brookhaven National Laboratory, experiments on Alzheimer's disease models were given doses equivalent to the radiation levels astronauts would be exposed to on a Mars mission. In Rochester, the research team evaluated the cognitive and biological effects in mice. The radiation-exposed mice failed tasks to remember objects or specific locations, suggesting neurological impairment. Vascular changes and accumulation of beta amyloid were observed in the brains of the mice. These protein plaques are a symptom of Alzheimer's disease. These findings clearly show that space radiation has the potential to accelerate the development of Alzheimer's disease, says O'Banion. NASA will need to take this factor into account when planning for the health of its astronauts. This research shows that space travel can affect not only our physical health, but also our cognitive health. So, what measures can be taken against such health risks in the future? Should space exploration and manned missions continue? Do you think these risks should be taken? Do you think more research should be done on this topic? Share your views in the comments, and let's discuss your thoughts on this topic. Perhaps this kind of research will shape the future of space travel and help us develop new measures. Is a healthy journey in space possible? We will continue to look for answers to these questions. NASA and other space agencies are developing various strategies to protect astronauts. These include more powerful spacecraft designs, radiation shields, and special suits. However, these measures may not be enough to block all the effects of cosmic radiation. Therefore, further research and innovative solutions are needed. NASA's measures against the health risks of space travel include monitoring the radiation levels to which astronauts will be exposed and continuously assessing their health during long-duration space missions. Special diets and medicines are also being studied to reduce the effects of radiation. Thank you for exploring this exciting and thought-provoking topic with us. Don't forget to subscribe to our channel and turn on notifications. See you in the next video. Bye. The space adventure continues. Stay tuned.